Hello guys, so today we will be studying about a very important topic in isomerism which is named as tautomerism. It is a very important chapter with respect to JEE Mains and NEET. Time and again one or two questions has been asked in these examinations directly or indirectly. So we have to revise it very thoroughly. Okay. So what is tautomerism? Tautomerism is basically, in case of any two isomeric structure, there would be interconversions which shall be possible and there shall be some energy barriers in between them. The basic fundamental between two isomers is there should be energy barrier between them. So in case of tautomerism also, the energy barrier, that is del E, is there. But this tautomerism is shown by two structures which we name as tautomers. Okay, which we name as tautomers. What are tautomers? Tautomers क्या है? Tautomers is basically two or more structures which undergoes rapid interconversions. Okay, so two or more structure, पेन और कॉपी हाथ में होना चाहिए. Two or more structure undergoing rapid interconversions at ordinary temperature. Okay, so at ordinary temperature these guys are undergoing rapid interconversions. Okay, so that is tautomerism, and the structures which are showing tautomerism is called tautomers. Okay, now this is the physical part of it, which basically explains that there is some energy barrier between them, but the energy barrier is not that much so that it can undergo interconvertibility in between themselves at ordinary temperature. Now, tautomers there may be two or three structures of tautomers. Let us take it like this: structure 1, structure 2 and structure 3. So let us take this three structure. So what will be the composition? Now first of all I have to know what kind of state are they. They are generally in liquid or gaseous state. Okay, organic compound generally in liquid or gaseous state. Now we have to find out, suppose there are tautomers, three structures are possible in a tautomer. So if I put this three structure in a beaker, तीन को हमने बीकर में डाल दिया ऐसे, ठीक है. So after that, what are the relative compositions of 1, 2, 3 in this beaker? ठीक है. It cannot be possible that everybody is having equal contribution. Okay, it is not possible that there will be 33.33% of 1, 33.33% of 2 and 33.33% of 3. There may be different compositions. So on which things that will depend? That will depend on basically three things. Number one is nature of solvent. Nature of solvent. Okay, write down. Nature of solvent. रिलेटिव स्टेबिलिटी. अभी देखो 1 का स्टेबिलिटी अलग हो सकता है 2 से, 2 का स्टेबिलिटी 3 से अलग हो सकता है. सो अकॉर्डिंगली इट्स कॉम्पोजिशन विल बी देयर. व्हिचएवर इज मोर स्टेबल विल हैव मोर अमाउंट इन दिस बीकर. सो नेक्स्ट इज रिलेटिव स्टेबिलिटी. ठीक है. नंबर 3 इज टेम्परेचर. Okay, so these are the three things based on which we will be determining the amount of different structures when put together in a beaker or solution. Okay, so these are the things that we are going to discuss in tautomerism in detail, and I have given you the introduction to it. ठीक है, इसको नोट डाउन कर लो. Now we'll be discussing tautomerism's types. So there are basically two types of tautomerism that are getting exhibited in different types of organic compounds. Number one is triad and number two is dyad. Remember, triad is much more important than dyad. So do not get yourself lost in dyad system. So I will explain the dyad system first and then I will go into triad so that your mind gets grasped with only the triad system, because most of the questions will be asked on triad system. Let's go to dyad first. What happens is, this basically happens in case of cyanide group. If you see, this carbon and nitrogen both are basically polyvalent atoms. Okay? So if, and here I have put a hydrogen. So if this hydrogen shifts like this, then what happens? This structure becomes like this. Right? So it is basically what it is. It is isonitride, right? This is nitride, this is isonitride. So this is like this. This is basically isonitride. So this is your dyad system. Okay, so this is your dyad system. Dyad, why it is called dyad system first of all? Because this hydrogen shift which is occurring is happening from number 1 atom to number 2 atom. इस एटम से इस एटम में जा रहा है, तो 1 2 I can say it as 1 2 shift. So this is dyad system. इतना ही है, you have to just know what is dyad system. Do not go in detail to it. Let us come to the triad system and let us understand what is triad system very carefully. I will take a very simple compound, that is CH3. Okay, I will draw the hydrogen separately over here. Okay, CH3 C11OH. Now if you see, in case of triad system, the hydrogen shifts from, see, there is a functional group. This is the functional group part. So whichever atom is connected to the functional group, that is this carbon's hydrogens are called alpha hydrogens. Okay, functional group के साथ जो भी कार्बन लगा रहेगा, उसके साथ जो हाइड्रोजन रहेगा वो रहेगा alpha hydrogen. So if this alpha hydrogen shifts like this, then what happens? The structure becomes like this, right? The structure becomes like this. Now here the carbon is having 3 bonds, here also this is 3 bonds, so here you will have a double bond. So if you see, this was, what was this? Ethanol, right? Ethanol. What is this? What is this? Ethanol, right? Ethanol. Enol, okay? And there was a keto group, which is obviously an aldehyde because there is a carboxyl group. This kind of triad system is called keto-enol tautomerism. Okay? This kind of triad system is called keto-enol tautomerism. भाई लोग देखो, keto-enol tautomerism is the most simplest kind of tautomerism and the most important tautomerism. Okay? Most of the questions, in fact, all the questions that has been asked in most of the competitive examinations, barring few questions in some competitive examinations, are asked from keto-enol tautomerism. क्यों? क्योंकि आपका टेक्स्ट बुक में keto-enol tautomerism ही ठीक से पढ़ाया है. If you see in your textbook, keto-enol tautomerism has been given much importance. So any competitive examination will also give importance to that part only. So please do not get straight away to anything else. ठीक है? आपको keto-enol tautomerism को छान देना है पूरा एकदम, काट के पीस बना देना है. ठीक है? चलो. Ethanol. So this is called keto-enol tautomerism. Now let us see where from the hydrogen atom has shifted from in this kind of tautomerism. If you see this tautomerism, hydrogen atom from atom number 1 has shifted from to atom number 2. Here if you see, hydrogen atom from atom number 1 has shifted to atom number 3. So this is 1-3 shift. Okay. 1-3 shift of an hydrogen atom. You can write it down. 1-3 shift of an hydrogen atom connected to a carbon atom, which is again connected to the carbon atom containing the functional group, is called your triad system of tautomerism. Okay? So you can note it down, everything. We have discussed ketoenol and simple diad system. Now we'll go in details into ketoenol and different types of tautomerism. So now we will go in detail into ketoenol tautomerism. So let us take the simplest ketone of all. Simplest ketone क्या होता है? Acetone होता है. So let us take acetone. So CH3 CH3. ठीक है? Let us take acetone and let us see how does the ketoenol tautomerism takes place over here. So here is the keto form and here is the enol form. One of the alpha hydrogen is shifted from CH3 to O and thereby forming a double bond in between CH2 and the carbonyl bond that was there. Now we will come into ketoenol tautomerism. First of all, you have to know which form is more stable. This is the keto form and this is the enol form. Which form is more stable? See, always remember in normal cases the keto form is more stable due to resonance stabilization energy of कार्बोनिल बॉन्ड. ठीक है, इसका रेजोनेंस होगा तो ड्यू टू दैट स्टेबिलाईजेशन एनर्जी ऑलवेज द कीटो फॉर्म विल बी मोर स्टेबल. दिस यू हैव टू रिमेंबर. नाउ देयर आर टू फंडामेंटल्स दैट यू हैव टू अंडरस्टैंड इन ketoenol tautomerism. नंबर 1 इज if there is no alpha hydrogen, no tautomerism. ठीक है, if there is no alpha hydrogen, there won't be any tautomerism. Number 1. Number 2 is keto form is more stable due to resonance stabilization energy. ठीक है, okay. Next, let us check one example over here. If the compound is like this, show ketoenol tautomerism. First of all, in this kind of problem, you just see which is the functional group. Functional group क्या है? ये carbonyl bond आपका functional group है. So this carbon you have to see. Now this carbon is attached to this carbon, and does this carbon have any hydrogen attached to it? No. So no alpha hydrogen, hence no tautomerism. ठीक है? This is the very important part. बहुत सिंपल सा कॉन्सेप्ट है. ठीक है, बहुत सिंपल सा कॉन्सेप्ट है. इससे आपको 1-2 क्वेश्चन मिल सकता है. ठीक है, रिमेंबर इफ देयर इज ए फिनाइल बॉन्ड लाइक दिस, then also there won't be any hydrogen that is going to this oxygen. Why? Because first of all, this is a sp2 hybridized hydrogen over here, and this is in a ring which has got resonance stabilized hydrogens over here. So this is not going to move to this oxygen. Okay, so phenyl group रहने से भी आप उसको अल्फा हाइड्रोजन नहीं बोल सकते हो. ठीक है, ये आपको दिमाग में रखना पड़ेगा. और इसका रीजन भी आपको मालूम है, बिकॉज इट हैज गॉट रेजोनेंस स्टेबिलाईजेशन और भी sp2 हाइड्रोजन है, so it cannot move to this one. ठीक है, क्लियर है. नाउ we'll be going into some other examples also, क्योंकि हमको सीखना तो पड़ेगा. तो एक तो हम लोग सीख गए कि अल्फा हाइड्रोजन नहीं रहेगा तो आपका टॉटोमेरिज्म नहीं होगा. So let us take another example. ठीक है, ये वाला लेते हैं. So you can understand this is a bridge compound, and over here. Okay. Here is a now. Will there be any tautomerism possible in this compound or not? That you have to check. First of all, try to find out what are the carbons that are present. Here there is one carbon, right? Here there is one carbon. Now, this carbon is connected to two methyl groups, and one is this carbonyl group, another is this carbon. So, this carbon essentially has no hydrogen. So there is no alpha hydrogen with this carbon, so it is not possible. Next is this one. This carbon is attached to 1, 2, 3 bonds, so there is one hydrogen over here. So it can move like this. Can it? It should be able to move like this. So if it moves like that, then can I rub one of the bond over here, make it OH, right? And move this one out, and I have to put a double bond over here. This should be the enol form. Now, is this enol form possible or not? This is a very important concept that you have to remember. Remember, any bridgehead cannot have a double bond with it. This is defined by Bread's rule. Okay? This is due to tremendous amount of strain in the bridgehead that is developed. So, this double bond is not possible in case of any bridge compound connected with the bridgehead. Okay? So this was very important. We'll take another bridgehead compound to make it pretty clear. Let's take this one. Now, is any tautomerism possible over here? Yes. देखिए, इसमें तो आपका डबल बॉन्ड आएगा नहीं, लेकिन इसमें तो आ सकता है या इसमें तो आ सकता है. तो देखते, ये हाइड्रोजन अगर शिफ्ट करेगा, इसमें क्या था? इसमें हाइड्रोजन नहीं था, लेकिन इसमें अल्फा हाइड्रोजन है, तो ये हाइड्रोजन शिफ्ट कर सकता है. तो ये हाइड्रोजन शिफ्ट करेगा तो क्या होगा? ये बॉन्ड बन जाएगा आपका इधर OH हो जाएगा कि नहीं? ये OH बन जाएगा, ये OH बन गया, तो इधर पे आपका डबल बॉन्ड आ सकता है. दिस इज नॉट ब्रिज हेड, सो इट इज पॉसिबल. ठीक है, और एक हो गया, और एक करते हैं. Now, in this one, is there any possibility of keto-enol tautomerism? Let us check. So, here you can see carbon has 3 bonds. So, obviously there will be one hydrogen. Here also there will be one hydrogen. So, alpha hydrogen है. So, alpha hydrogen जा सकता है. जाएगा तो क्या होगा? देखते हैं. ठीक है? हम ये वाला ले. ठीक है, OH ये वाला नहीं लेना है. We are taking this one, so this will be hydrogen. This will be like this. ये स्ट्रक्चर हो सकता है कि नहीं हो सकता है? Again, Bread's rule comes into action. Bread's rule एक तो क्या है? ब्रिज कंपाउंड के लिए ब्रिज हेड कार्बन के साथ आपका डबल बॉन्ड नहीं रह सकता है. नंबर 1. नंबर 2 इज ए रिंग कार्बन, ए सिंगल रिंग कार्बन कैनॉट होल्ड 2 डबल बॉन्ड. ये जो डाइंग स्ट्रक्चर है ना, डबल बॉन्ड, एडजेसेंट डबल बॉन्ड, it cannot be stored by a single ring carbon due to the same concept of tremendous strain development. ठीक है, तो Bread's rule के लिए आपको 2 चीज याद रखना पड़ेगा. नंबर 1 is a ring carbon can't hold 2 double bonds. Number 1. नंबर 2, ब्रिज हेड पे डबल बॉन्ड नहीं. ठीक है, नंबर 1 रिंग कार्बन, एक रिंग कार्बन में 2 डबल बॉन्ड नहीं हो सकता है. नंबर 2 यू हैव टू रिमेंबर, ब्रिज हेड जो होता है उस पे डबल बॉन्ड नहीं हो सकता है. वेरी इंपॉर्टेंट कॉन्सेप्ट. ब्रेड्स रूल क्वेश्चन are not asked directly but indirectly this role is pretty important. ठीक है, समझ में आ रहा है? देखिए कीटो एनॉल टॉटोमेरिज्म में हम लोग बहुत कुछ सीखे है ना, और भी सीखेंगे. Now next we will discuss about the effect of solvent. Let us take this compound. Okay, so this is the keto form. Well understood? ठीक है, keto form है ये. Now, what will be the enol form? What will be the enol form? The enol form will be like this. ठीक है, इसमें हम लोग को डबल बॉन्ड लगाएंगे, इसमें फिर से डबल बॉन्ड O2H5. ठीक है, this will be the enol form. Now which one will be more stable? Traditionally I can say keto form will be more stable due to resonance energy. Now if you see this structure, pretty important, there will be hydrogen bonding between these two atoms. Stability बढ़ेगा, हाइड्रोजन बॉन्डिंग है, स्टेबिलिटी तो बढ़ेगा. नेक्स्ट, देयर इज conjugation over here. So there are two factors which are increasing the stability of enol content. Number one, chelation, intermolecular hydrogen bonding. Number two, this one, conjugation. So आपको ये चीज दिमाग में रखना है, ठीक है? You have to keep it in mind that chelation and conjugation will define the stability of enol content in the mixture. वो जो मिक्सचर डाले थे ना 1, 2, 3, ठीक है, उसमें आपको chelation और conjugation will decide whether this enol will be stable or not. ठीक है? So let us take this one. Now first of all there is one question. Okay, wait. Here this CH2 has given one alpha hydrogen and not this. Why? Because here the double bond was formed here, and if I wouldn't have kept the double bond over here, it would have been over here. इसमें हमारा लॉस कहाँ पे था? लॉस दो जगह पे था. ये डबल बॉन्ड अगर यहाँ नहीं होगी, इधर होता, तो कॉन्जुगेशन नहीं होता, तो नहीं हो सकता. Next, more substituted double bonds are much stable. ठीक है, मोर सब्स्टिट्यूटेड डबल बॉन्ड, तो घेरा हुआ जो डबल बॉन्ड रहेगा वो ज्यादा स्टेबल रहेगा. सिक्योरिटी गार्ड का कॉन्सेप्ट तो हमने समझाया आपको पहले, ठीक है? सिक्योरिटी गार्ड जितना ज्यादा है उतना स्टेबल है, ठीक है? ओके, नाउ सी इफ दिस इज प्योर लिक्विड, ठीक है, प्योर लिक्विड, तो अभी हमको इफ यू आस्क मी दैट व्हिच वन विल बी इन मोर कंटेंट इनसाइड द कंटेनर, एक्चुअली स्टिल दिस वन विल बी having some contributable composition, but still not more than this. Okay, so in case of pure liquid, this will be around 92% the keto form, and the enol form will be 8%. Okay, but still 8% is due to chelation and conjugation. It has increased. Now, if I dissolve this solution in water, what happens? So, if it's a water solution, what happens? See, in case of water, this OH will try to form hydrogen bonding with water. So if it tries to form hydrogen bonding with water, then will it form the intermolecular hydrogen bonding? No. So the intermolecular hydrogen bonding will suffer. So chelation का जो पार्ट था वो पानी में नहीं रहता है. अगर नहीं रहता, जो 8% हुआ, 8% से कम होगा या ज्यादा होगा? 8% कब था? जब चिलेशन और कंजुगेशन दोनों था. अभी आपने पानी में डाल दिया, पानी में क्या चला गया? कंजुगेशन अभी भी है, लेकिन चिलेशन नहीं हो पाएगा. क्यों? क्योंकि पानी के साथ वो इंटरमॉलिक्यूलर हाइड्रोजन बॉन्डिंग कर रहा है. क्या कर रहा है? इंटरमॉलिक्यूलर हाइड्रोजन बॉन्डिंग. सो इंट्रा वाला जो चिलेशन है वो तो होगा नहीं, है ना? अभी देखिए मेरा ये दो हाथ है, इन दोनों में बॉन्डिंग चल रहा है, ठीक है। तो अभी अगर दूसरा कोई आदमी आ गया, मेरा ये हाथ को खींच के उसके तरफ ले गया, तो ये बॉन्डिंग होगा क्या? नहीं होगा ना। तो उसके लिए बोल रहा है, तो चिलेशन वाला कॉन्सेप्ट तो चलेगा ही। तो क्या होता है इसमें, इसका परसेंटेज बहुत कम हो जाता है, ठीक है। यू कैन अंडरस्टैंड बाय सीइंग द मैग्नीट्यूड। नाउ इफ यू सी, इफ आई यूज ए non-polar solvent, say hexane, then what happens? Now in case of hexane, this chelation continues because hexane is not pulling it for hydrogen bonding, right? हेक्सेन को हाइड्रोजन बॉन्डिंग करने का कोई शौक नहीं है, वो तो सिर्फ पानी को रहता है। सो हेक्सेन विल नॉट पुल दिस फॉर हाइड्रोजन बॉन्डिंग, चिलेशन विल स्टैंड, conjugation will stand, and obviously the percentage of the enol content will increase more and more, okay, and it will be having a percentage of approximately 46% and here it will be 54%, okay. So see, in case of hexane the enol content is much more, so enol content has an order basically, okay. So see, if it is a non-polar solvent the enol content will increase, if it is a polar solvent the enol content will come down, okay. So there is an order for this, I'll give you the order first, you have to note down karna hai, okay. The order is enol content order, you write enol content order, hexane more than benzene, more than acetone, more than methyl alcohol, more than water, ठीक है. So this is the order in which the enol content will lie while I change the solvent. जितना नॉन पोलर होगा enol बढ़ेगा, जितना पोलर होगा enol कम होगा, ठीक है. So that was the basically the concept that I wanted to explain about the solvents, ठीक है. एक प्रॉब्लम कर लेते हैं, चलिए. नोट डाउन कर लिया ना? ठीक है. So this is a compound, its enol form will be ठीक है. This enol form will be this one, right? Now what happens? Which is more stable in CCl4 solution? Which is more stable in CCl4 solution? आपको क्या चेक करना है? सबसे पहले फंक्शनल ग्रुप, ठीक है. इसका फंक्शनल ग्रुप और इसका फंक्शनल ग्रुप चेक कीजिए. इसका फंक्शनल ग्रुप क्या है? OH. OH के साथ हाइड्रोजन बॉन्डिंग होता है, इसे H इधर रखिए, तो होगा हाइड्रोजन बॉन्डिंग होगा, तो चिलेशन होगा. चिलेशन अगर होगा, कौन सा टाइप ऑफ सॉल्वेंट में इसका अमाउंट बढ़ेगा? पोलर में या नॉन पोलर में? देखिए पोलर में होगा तो पोलर तो इसको खींचेगा तो चिलेशन होगा नहीं, उसका अमाउंट कम होगा. हमने कौन सा सॉल्वेंट दिया है? CCl4. सो CCl4 में इसका वैल्यू बढ़ेगा, 76% रहता है, ठीक है. ये आपको याद रखने का जरूरत नहीं है. यू कैन जस्ट से दैट enol is much more stable in CCl4 solution because CCl4 is non polar, ठीक है. और एक करते हैं, लेते हैं. सो दिस इज द इनॉल फॉर्म एंड दिस इज द कीटो फॉर्म। आपको बोलना पड़ेगा कि कौन से में ज्यादा स्टेबिलिटी आएगा। फर्स्ट ऑफ ऑल चिलेशन है या नहीं है, वो देखिए। इसमें चिलेशन नहीं हो सकता है क्योंकि दिस H एंड दिस O इज मच फार अवे, ठीक है। दिस H एंड दिस OH इज मच फार अवे, सो चिलेशन का कॉन्सेप्ट नहीं है इधर, तो चिलेशन का चीज आप भूल जाइए। सो इसमें आपको सिर्फ कॉन्जुगेशन देखना है। कॉन्जुगेशन तो हो रहा है, इसके बाद देखिए अल्टरनेट डबल बॉन्ड है, कॉन्जुगेशन हो रहा है। सो चिलेशन नहीं है, कॉन्जुगेशन हो रहा है। तो अभी आप इफ यू यूज वाटर एज ए सॉल्वेंट, सो वाटर इज नॉट गोइंग टू रिड्यूस इट्स स्टेबिलिटी, सो दिस विल अगेन बी मोर स्टेबल इन वाटर। इस केस में क्या था, CCl4, पर ये वाला केस में वाटर में स्टेबिलिटी ज्यादा है क्योंकि इसमें तो हाइड्रोजन बॉन्डिंग था ही नहीं इंटरमॉलिक्यूलर, तो इसका स्टेबिलिटी के ऊपर जो हाइड्रोजन बॉन्डिंग का कंट्रीब्यूशन था दैट वाज नॉट देयर। सो वाटर इज नॉट बीइंग एबल टू रिड्यूस एनी पार्ट ऑफ इट्स स्टेबिलिटी, यू जस्ट हैव टू टेक द कॉन्जुगेशन पार्ट एंड दिस इज स्टेबल इन वाटर, ठीक है। हो गया आपका। देखिए कीटोन टॉटोमरिज्म वी हैव डन a lot of examples, we'll do other examples also, okay। so ये जो है आप नोट डाउन कीजिए।